So in this case, we are going to consider as a continuation from the previous class that we had. Remember, we managed to work out the basics, which is some of the recap that we had from our grade 11. So it is still the same part on this class that we are going to have. We are still on our recap from what we have done before. So we're going to look into one or two problems that according to this part of the trig identities and also the proofs. So in our case, we are going to consider the Pythagorean identity. Some they refer this one as the square identity. All right, if we are given angle x, then the cos squared of angle x plus the sine squared of angle x is supposed to give us a 1. That is our Pythagorean identity. Where actually or exactly was this taken from? From the word itself, Pythagorean, from our Pythagoras theorem concept. Remember, we managed to work onto that Pythagoras. So let's just consider to say we have got a triangle that is referred to as ABC, just like the previous case that we had. Then we referred to that. The hypotenuse square, which is the C in this considering to B and A, it can be given that C squared is equal to A squared plus B squared. That is from our Pythagoras theorem. If we were to consider now in terms of the ratios from our trig ratios, there's something that I want us to see here from our trig ratios. The sine of angle A and also that of angle B can be determined. So in our case, we are simply going to work with one of the angles. As we saw from the formula or from that theorem, if it is cos squared x plus sine squared of x, it means we are referring to the same angle x here. If this is 30 degrees, this must also be 30 degrees. So meaning to say, in our case, we're just going to choose one of the angles between A and what and B. So let's say we have got this angle B. Let's say we choose to work with angle B. It follows that we can determine these trigonometrical ratios from the angle of B. It follows that this is our opposite, the one that is facing the angle that we are working with. So we've got the opposite, the adjacent, and our hypotenuse, which is what? Which is C. So thus, the ratios can be determined, sine and cos. We are focusing the sine and the cos, guys, not a tan, okay? So the sine of angle B is going to give us what? From our SOHCAHTOA concept. That's opposite over the adjacent. Opposite over adjacent. So that's B over what? Over A. From those sides that you're given, or you can write AC over BC. It's up to you. It is the same thing for the cos of angle B. We can use the same concept, the adjacent over what? Hypotenuse. Our adjacent, that is A, and our hypotenuse, that is what? Here, guys, where am I getting this? Where am I getting opposite? B over what? Over C. hypotenuse. Opposite over hypotenuse. This one adjacent, which is A, the hypotenuse is C. So this is what you're going to have. Representing what? The trig ratios of a sine and a cos. If we are to consider here from our Pythagoras theorem, we have the C, which we also have this side. And it is in the denominator for both ratios. So from this, let's divide by what? C squared. Because we have it in the denominator. So if we were to divide this one by C squared, that was going to give us what? A 1. So 1 is equal to A squared over C squared. It is the same as A over C squared plus the B squared over C squared. It is the same as B over C squared. It is one and the same. So if we are to consider it properly, we can see that we have these A over C, A over C, representing what? The cos of B. So it therefore follows that this can be written as the cos of B squared, which is cos squared B, plus the B over C, which is the same as what? The sine of B, but being squared. So it is going to be the sine squared of B. So are we seeing that? That is our Pythagorean identity. We can actually prove it. We have the proof. In terms of angle B, we can also do this in terms of angle A, because what is important here is that we must have the same angle here. B, this is also B. As long that is happening, guys, we have got our Pythagorean identity. So that is the major case that you must have. And if you are to consider this one, you must know it. Since for the identities that we are given, this is the only section of our identities, guys, in our formula sheet, where we do not have that part of the Pythagorean identity. So you must know this one in case that you are to use it. But we have been working with this from our grade 11. So that is, you can as well use the basics that you had before. So this is it, guys. Our Pythagorean identity can be what? Can actually be proved from where it was taken from. So here we can just write in any concept. In any ways, are you going to write in terms of the x cos squared of x plus the sine squared of x is equal to 1. So it therefore follows that I can make cos squared the subject. I can also make sine squared the subject. So therefore, from this part, cos squared of x is equal to what? Take the sine squared, is going to be negative on the other side. So that's 1 minus the sine squared of x. We can as well make this one the subject, the sine squared. So it follows that the sine squared of x will be equal to what? 1 minus cos squared of x. We're going to take this to the other side. So from that Pythagorean identity that we managed to prove, we can form others identities from this, which is we can make cos squared the subject, which will be equal to what? 1 minus sine squared of what? Of x. The sine squared of x, which will be equal to 1 minus cos squared. Meaning to say, wherever we see a sine squared, if there is a need for us to substitute with this, we can do that. Wherever there's a cos squared, we can substitute with this. So identities, guys, it's all about revision. The more questions that you work with, the more understanding It's all about more questions. That's why you see trigonometry, guys. There are a lot of questions, a lot of questions. So it tells you as an individual, you are supposed to do more than those questions that you see. You're supposed to work out as many as you can. So that is it. We're going to see or look into that one later on. Then we also have the tan of theta, which is sine over cos. All right. The sine of theta is taken as the sine over cos. Actually, this is basically from the same concept, guys. We can actually just consider this to say, let's say there is a right angle triangle here, and this is our theta. All right. And we've got our sides A, B, C, whatever that we have there. Remember that the sine of theta being opposite over the hypotenuse was going to give us B over C, and the cosine of theta being adjacent over hypotenuse was going to give us A over C. Now let's just form something here. Let's just divide and see what is happening for the sine of theta over the cos of theta. The sine of theta over cos, sine is what? B over C. So that's B over C divided to the cos A over C. This is a division that we are having here, which we can introduce a multiplication, and thus B over C, our numerator, times, what are we going to do? We invert the second fraction, we interchange. So C is going to be on top over what? Over A. So you interchange C on top, A below. So that's, these two can cancel the numerator what? Denominator concept. And thus we are going to obtain 1 and 1 here. So B times 1 is B. 1 times A, that is what? That is A. This is the answer for the sine of theta over what? The cos of theta. It gives us B over A when simplified. So is it true? Because we are saying it is the same thing as what? The tan of theta. So from this triangle, if we were to determine the tan of theta as a ratio from the triangle, was it going to give us the same thing? Remember, from our SOHCAHTOA concept, opposite over what? Adjacent. According to this, this is our opposite, and that's our adjacent. So B over what? B over A. Exactly what we are seeing from the triangle. From this trigonometric ratio, B over A. It is the same thing as what we see the ratio of sine over cos, B over A. Remember, we simplified the sine over cos on its own. We have from what we obtained. But it is giving us the same thing as what the tan is having. So therefore, the tan of theta is equal to what? Sine over cos. Sine theta over cos theta. That's it. So we are not going into those basic part of our grade 10. Remember, in our grade 10, we are now considering the use of the sec, cot, and so on. Those sec, cosec, cot, this and that. In our grade 12, we just understand that tan is sine over cos. No much to be considered. So all you just need is to know the applications. As you can see, guys, they have reduced a lot of things. Like from what we had, there was, guys, there are so many things. Remember, we talk about the 6 trigonometrical ratios, but in our grade 12, we do not consider the 6. We just work with what? 3 trigonometrical ratios. So on those 3 trigonometrical ratios, the tan involves the sine and the cos at the same time. Thus, it makes it to be an identity now. That's an identity now. All right. So anyways, this is it, guys. In order for us to apply or to use this, all right, the identities, definition, concept, and what? Theory. A trigonometric identity is a mathematical statement that is true for all values of the angle except those which the statement is not defined. It must be true. So identities are now used in order to simplify trigonometric expressions by knowing them. We can simplify trigonometric expressions. We can even prove them, not just to simplify, but also to prove those trigonometric identities, to say the left-hand side is equal to the right-hand side. So in your grade 11, as a previous stage, there are two fundamental identities that you are required to know. The first one being our Pythagorean identity, the one that we discussed before, and also this tan being equal to sine over cos. So these are the basic, the fundamental, the beginning of your identities, where you start to say, now I'm working with identities. That is where you start. So failure to answer questions on the fundamental, guys, is going to be difficult for us to understand those compound angle, those double angle. You see, so that is why we need these basics. All right. Anyways, identities have to be used in most cases to simplify expressions or to prove that the left-hand side of an identity is equal to the right-hand side of the identity. Proving that the left-hand side must be equal to the right-hand side is another aspect you are supposed to know. Besides the simplification, besides the simplifying, proving is very, very important. So these are some of the tips that you are going to use or to consider whenever you are to simplify or to solve problems where identities are to be used. In our case, working with the Pythagorean and that identity of what? Of a tan. The tips that we are going to consider. One, we must write expressions in terms of sine theta, cos theta only. We must see the sine and cos, meaning to say wherever there's a tan, change that tan to a sine and a cos. Change it. And the reciprocal of that tan, 1 over tan theta, as tan theta, it's sine over cos. So reciprocal, you're just going to interchange cos over what? Cos over sine. This is what? The reciprocal, 1 over tan theta. So that one, guys, you can also consider it as an aspect for you to, just like the basics, all right? So when dealing with fractions, find an LCD or the LCM and add where addition is to be what? Where addition is to be done. You have to add, you must have the LCD or the what? Or the LCM, the lowest common multiple or the lowest common what? Denominator. Factorize expressions where possible. Where it is possible, please do factorize. And in most cases, you are going to be considering those, especially the, let's go back to this 1 minus sine squared. You see this part here, in order for you to factorize such, we are back to the difference of two squares. So remember also those factorizations as you had before, that a squared minus b squared is equal to what? A minus b into a plus b. That can actually be very, very helpful. Very, very helpful in your simplification. As we have got 1 minus sine squared, we know that if it is 1 minus sine squared of x, 1 is same as 1 squared. So meaning to say there are two brackets, 1 minus the sine of x, another one, 1 plus what? The sine of x. As an example, this is what I'm just trying to say. So know those factorizations, difference of two squares, where it is possible, use that to simplify. All right, use that in your simplification. All right, so without wasting our time, we are going to consider one or two questions which is to apply to what we have learned so far. Example 1, express the sine of theta over the tan of theta as a single trigonometric ratio. Single. Is it going to be just a tan? Is it just going to be a sine? Is it going to be a cos? That is a single trigonometric ratio. Is it going to be one of these? All right, so how can we simplify this? Given that the sine of theta over the tan of theta, remember that the tips there, the tan of theta, we must get rid of by using its equivalent identity. Our answers best to be written as sine and cos only, meaning to say where a tan is, replace with its equivalent, sine over cos. So thus we're going to have the sine of theta, this one. But we are changing the tan to be in terms of what? Sine and cos. So that will be sine of theta over cos of theta. So this here is a single, it's a single thing, it's a single term. As it is a fraction like that, you consider it as a single term. So what does it actually mean? In order for us to understand this much better, it simply means I have the sine of theta, this one, in the numerator, divided to this sine over cos. Sine of theta over cos theta. This is what it means. Remember, guys, it is not just about trigonometry here. Simplification, you refer back to your fractions, everything. Where a division is, we get rid of that by introducing what? A multiplication. So this here is same as sine theta over 1. So it was just the same as the sine theta over 1. We introduce a multiplication. By doing that, you interchange the second fraction. This is our first. Then the second one is the one that you interchange. So cos on top, the sine in the what? In the denominator. So it's going to be cos of theta over. The sine is now in the denominator. The moment you introduce the multiplication sign, you interchange the second fraction. So this is it. Sine and a sine. Numerator to the denominator. So this is 1. This is going to give us 1. So that was going to be 1 times cos, which is the cos of theta over what? 1 times 1, which is 1. So cos theta over 1 is what? Is cos theta. So that is it. We have got a single trig there. Cos theta. Thus, we have expressed this in simplest form. So those are same questions now that you'll be given in exam where the aid was to simplify. To express this is just like simplify. So they can change this and say, prove now, prove that. You see what they do in exam? Prove that. The sine of theta over the tan of theta must give you what? Cos theta. It's a question that they can also give you like that. So do you see that? To prove is just to simplify. Only that there you are given an answer. They want you to show that exactly what is on the left-hand side is equal to what is on the right-hand side. That's the only thing. But already you've been simplifying before. Only that you were not given the answer, so you're just writing the answer in the way that you understand. So proving is an aspect which is under simplification. Only that you have the answer. That is it. All right, let's consider question 2. example number 2. Prove the following identity. You see what I'm trying to say? You have already been simplifying, so there's nothing new here. If you were going to simplify the left-hand side as a, let's say the question was just simplify this. How are you going to simplify? That is the same thing about the proof, guys. Do not even be do not worry, guys, to say now this is proof. What how am I supposed to prove? Only that on the proof, you choose a side to work from, and in that case, choose the most complicated side, that is where there's a lot of things like we know that we can simplify stage by stage. So in this case, I'm going to take the left hand side, which is equivalent to 1 minus the sine of what? Of beta into 1 plus the sine of what? Of beta. Everything over what? Cos squared of beta. How can we prove that it is equal to 1? All right, there are brackets in the numerator, and that's a special type. Same terms, only that the other one is a negative, the other one has a positive. A difference of what? 2 squares. Remember the concept. From our difference of 2 squares, a squared minus b squared was taken from a minus b into a plus b. So I have these, I can rewrite in this manner. So that's here. This is your A, this is your B, this is your A, this is your B. So if you're going to have A squared minus B squared, it was going to be 1 squared minus the sine beta squared, A squared minus B squared. That is what it's going to be. So meaning to say 1 squared, that is what? 1 minus the sine beta squared is the same as what? Sine squared of what? Of beta. Everything over the cos squared of what? Of beta. So this is where we are. In this case, it was up to you to rewrite a cos squared in terms of this, because we know it is the same. Remember, from the Pythagorean, we ended up with the cos squared of x being equal to 1 minus sine squared of x. Remember that. So what I'm trying to say is that I can rewrite this as a cos squared, or I can write a cos squared as this. It was up to you. So in my case, I'm just going to take the numerator, change it to a single term. 1 minus sine squared x is same as what? Cos squared x. So therefore, this whole part is same as cos squared of what? Of beta. Everything over the denominator as it is cos squared of beta. We are simplifying. But as we are simplifying, we are proving that this is supposed to give us what? A 1. Exactly what is on our right-hand side. So in our case, we can see that we have managed to prove the left-hand side is exactly equal to the right-hand side. Exactly what we wanted. So you see, simplification, guys, proving one and the same. What were you doing here? You were simplifying, but only that you were given the answer. Considering this exercise, we are going to go through this one together. They gave us, to simplify the following expressions, so we're just going to use the idea, the knowledge that we have so far. 1.1, tan x times the cos of x, all right? That's the tan of x times the cos of x. We can see something is weird there on the what? The tan of x. Let's get rid of that. The tan of x is the same as what? Cos over sine. So guys, just like that. So this is, the sine of x over the cos. All right, I just hope I did not say the other way. All right, so this is it. So how can we simplify here, guys? This is same as over 1, and as we do understand the numerator denominator concept, this cancels gives a 1. So we're going to remain with sine x times 1, which is the sine of x, over what? 1 times 1, which is 1. And that's the sine of x, just like that. 1.2, we are given again to simplify. As we can see, it is similar to the previous question that we had 1 plus cos of theta into what? 1 minus cos of theta. And thus everything is over the sine of theta. Remember, we talked about the a squared minus b squared being a minus b into a plus b, our difference of two squares. A, B, A, B. Only that it's separated by what? The other one is a plus, the other one is a minus. So guys, let's apply our difference of two squares. A squared minus B squared. 1 squared minus what? Cos theta squared. So that was going to give us 1 minus cos squared of theta. Everything over what? The sine of theta. Just like that. So in this case now, this time you're forced only to look into the numerator, the one that is being squared, 1 squared minus cos squared. This is the only one that we can change. Sine theta, guys. No, 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 no. On our identity, there is sine squared, not sine theta. On those Pythagorean, remember that the sine squared of x is equal to 1 minus what? Cos squared of x, as well as we have the same cos squared being 1 minus sine squared of x. So in our case, we are simply saying where we have 1 minus cos squared, 1 minus cos squared, we rewrite it as a what? As a sine squared. So this simply means it was going to be equal to a sine squared of what? Of theta. Everything over the sine of theta. Just like that. Sine squared of theta, there are two of them. Sine times another sine over what? A sine. So this cancels, you remain with one of them. So there are two. So if you cancel, guys, one is going to remain. So you're going to remain with what? Sine of theta. Is it in the simplest form, this one? Yes, it is in simplest form. There's nothing that we can do. It is not a proof question where you have to check what was the answer there. There you simplify until you can see that this is in simplest form. There is nothing that I'm going to do. There is no substitution to be done. Nothing, nothing. In that case, you say that you are done. All right, let us move on to 1.3. Again, it is to simplify. So we must try by all means to do this up to when our answer is in simplest form. So that is, we are given this 1.3, 1 over the cos squared of theta minus 1. All right, how do we go around this? 1 can be written as any number, a over a, b over b, 2 over 2. Remember that. So we can rewrite the 1 in the denominator of the, as a denominator, as this one, as this, in the denominator cos squared. So 1 can be rewritten as what? We're going to have 1 over cos squared theta minus. This 1 can be written as cos squared of theta is going to be cos squared theta over cos squared theta. In that case, it makes our subtraction easier because we do understand if the denominators are the same like this, we simply consider it as it is, then combine the numerators together. You just have to combine them together. That's it. 1 minus cos squared. Combine just like that. Combine them. So now that we have got this, it is written in simplest form, guys. As long there's a substitute to something, means it is not in simplest form. As long there's a substitute, remember 1 minus cos squared, same as what? Sine squared. So this, it has a substitute. So that's a sine squared. The sine squared of theta over what? In the denominator, I have a cos squared of theta. So looking into this, guys, there is no difference. Sine squared over cos squared. There is no difference in rewriting this as the sine of theta over the cos of theta squared. There's no difference. And that sine over cos represents what? It represents a tan, remember? So that's tan theta squared, which was going to be tan squared theta. So this whole part, sine over cos, is equivalent to what? The tan squared of theta from this understanding. That is how we can simplify. It is now in simplest form as a single trig, tan, as a trig of a tan. So this is how they play around with you in exam. You have to be very careful in your simplifications. All right. On question number 2, we are now asked to prove that the left-hand side must be equal to the right-hand side of this trig that we are given here. So let's look into it. All right, there we are given. Just going to consider the left-hand side as of my case. So that's 2. Considering the left-hand side, I have got 1 over 1 plus the sine of theta plus 1 over what? 1 minus the sine of theta. All right, so there is a little bit complicated because there are fractions to be added there. So combine them as a what? As a single fraction. We must determine the LCD of the given denominators, the LCM. There is 1 plus sine theta, 1 minus sine theta. So you just have to combine these together. 1 plus the sine of theta, 1 plus what? 1 minus the sine of theta. You just have to combine as it is. So with our LCD, we are going to combine or add these two fractions together. Thus, 1 plus the sine of theta, another bracket, 1 minus what? The sine of theta. So this is it. Remember, the division concept is the LCM or the LCD divided to the given denominator. So if you were to take this LCD, then you divide by the denominator, 1 plus sine of theta. As you can see, these we're going to cancel. Then you remain with what? 1 minus sine theta. So you're going to remain with 1 minus sine theta because this was going to cancel. So 1 minus sine theta, the one that you remain with, multiplies the numerator. Be very careful, guys. So it's 1 into 1 minus the sine of theta plus the same thing, denominator to the what? To that. Your LCD to this denominator. So 1 minus sine theta was going to cancel. You remain with 1 plus sine theta. So that's it. You're going to remain with 1 plus sine theta, but being multiplied by what? By the 1 in the numerator. So that's 1 plus the sine of theta. Let us quickly expand these brackets and simplify. As you are multiplying by 1, there is no effect. 1 times this just remains as it is. Also here remains as it is, plus the sine of what? The sine of theta. Everything over what? So for now, looking into our answer, we can see that there is a cos squared. There is no sine there. It is in terms of a cos in the denominator. So how can we obtain that? We are back to that difference of two squares concept. A, B, A, B. One is a plus, another one being a minus. So that's a difference of two squares, which was taken from what? 1 squared minus the sine of theta squared. So that's 1 minus sine squared of theta. All right, so with this, we can simplify our numerator. The numerator, there are like terms to be considered there. So quickly collect the like terms. The minus sine of theta plus the sine of theta, that was going to cancel, guys. Minus 1 plus 1 is just like minus 1 plus 1. So that was going to cancel. Minus 1 plus 1 was going to cancel. So this was gonna cancel, guys. So you're left with what? You are left with what? You are left with 1 plus 1. So 1 plus 1 is what? Is 2. So that's 2 over 1 minus the sine squared of theta. Remember that 1 minus sine squared of theta from our Pythagorean identity is same as what? Cos squared of theta. So as you're working with your Pythagorean, I think it's better for you to just write them cos squared x plus the sine squared of x is equal to 1. You write them aside before you attempt your questions. Then you also write cos squared of x is 1 minus what? Sine squared of x. Sine squared of x is what? 1 minus cos squared of x, just like that. You guys, once you see 1 minus sine squared, you know, it's cos squared, like that, all right, as it is. So this is exactly what we had on the right hand side, exactly our right hand side. So we can say the left hand side in this case is exactly equal to the what? To the right hand side, just like that. So these are the typical questions that you might be given in your revisions. So do revise as many questions as you can. Like I said, trigonometry, guys. In fact, mathematics, that's why it is a daily subject. Revise it daily as an individual to make sure that your preparations are smooth. They are very smooth, and you won't miss your examinations, I tell you. So that is how to prepare. Do revise as many questions. In fact, for all subjects that do have calculations, your physical sciences, those other calculations that you have, make sure that you prepare, you put time into them, understand the basics, and do revise as many questions as you can. Do question papers as well. Question papers are meant for revision to say, okay, I have the basics of the quest of the topic. Without the basics of the topic, guys, do not open question papers. Why do you open those? You'll be shocked because you do not have the basics. So have the basics first. Then after that, open as many question papers as you can. That can help you to attempt these questions. So that is it, guys. Till we meet again.